In this demo, I'll be showcasing Delphix data virtualization using our continuous data platform. We will also cover profiling and masking using Delphix continuous compliance platform. And we will create Delphix DataPods for self-service, and as well as to show you how all this can be automated using API, and in this case into Jenkins pipeline. So first, let's look at the source. So our source database is this Postgres custom master, and the file system that we will be using is this FS custom master. So the first thing we'll do is we will take both the database as well as the file system, and we will mount them to the masking environment. So from the source database, we pick the latest snapshot, and we will mount it to Postgres target. That's where the masking environment is. We'll choose the database. Postgres user is correct. I will change the mount point to something more readable. Let's call it ALDB must. The Postgres port will be 6433. Next, the virtual database will be called ALDB must, and it's going into the masking environment. Next, submit. So we'll do the same thing for the file system. Pick the latest snapshot, mount it to Postgres target. Unstructured file is correct. The user is Delphix, that's our OS user. Next, again we will change the mount point to something more readable. We'll call it ALFS must. And next, the virtual file system, we will call it with the same name, ALFS must. It's going into the masking environment. Next, submit. So now we have provision virtual database as well as virtual file system into the masking environment, and both are already up and running. So the next thing we'll do is we will mask the database, and we will not be masking the file system because in this demo the file system represent the application, so there's no need to mask that. But if your data extend into the file system in the form of JSON, XML or CSV files, then you should be masking those as well. So let's pick the database. Let's go to our continuous data platform. First thing we'll do is add the application, and our application name in this demo is AL. We will then add the environment. Select the application that we just created. The environment name, let's make it easy. Let's call it AL as well. Select purpose, in this case we'll be masking. There's also tokenization and re-identify, but in this demo we'll just do masking and save that. So our environment is now ready. If you go into the environment, the next thing we should do is to connect to our database. So create the connection. The database type is Postgres. The connection name, make it simple, call it AL. The schema, I happen to know that is public. The database name is 290USD, and the host is .60. Port, as you saw earlier, I use 6433 to connect to the database. Postgres. Okay, let's test the connection. Successful. Save. Now the next step is to create a rule set. The rule set is where you can selectively choose what to mask and what to ignore. So in this case, let's go ahead and create the rule set. Let's give it a name, make it simple, call it AL, select connector, the one we created earlier. Now immediately using the connector, the compliance engine are able to go out to the database and grab all the tables. So the one that we are interested in is number one, this node here, the index, and then we will include address, city, country, date of birth, first name, last name, phone, postal code, state. So 10 altogether. We save that. Now we can go to the inventory and look at what we have selected. So all the 10 tables are here, and note it's just indexes. The address field is this one over here, city, country. So the thing to note here is that the algorithm column, there's nothing assigned yet because we have not yet run the profiler. So we'll now can go ahead and create the profiling job. I'll call it AL profile job. The rule set is the one we created earlier. Now the profile set, we're going to choose GDPR as an example. So basically what this means is that the profiler will conform to the GDPR regulation in terms of what is considered sensitive. Let's just remove this guy and save. So we might as well also create the masking job since we're already here. Call it AL masking job. Masking method is we can choose between in place or on the fly. In place means the masking engine will replace data in the source database. On the fly means it will create a separate new database of masked data and will not override the source. So in this demo, we'll choose in place. The rule set is the one we created earlier. The rest of the stuff are just to fine tune in terms of performance, especially if you have a large data set to mask. So you might want to change some of these in terms of the streaming, memory use and all that. So we're gonna remove this email from here, save this job. So basically the profiler and the masking job is ready. But before we jump into doing all this, let's just make sure that we can connect to our masking database, which we provisioned earlier. And I have this SQL statement here that I've done earlier, basically to extract the 10 columns that 10 tables that we selected earlier. So I'm going to run this against the masking database. So let's choose mask as a source, run it into a new tab, and let's call this mask. So as you can see, the source and the mask right now is exactly the same because we have not yet run the masking job. So now let's go back into the compliance engine, and the first thing we'll do is run the profiler. So this will take a short while, and the job is completed. Now if you go back to inventory, we can see that no, there's no PII, so no algorithm is suggested there. Address field should be PII, so the algorithm address line secure lookup is recommended by the masking engine. City is not considered PII. There will be millions of people living in that city. Country as well. Date of birth should be PII, so date shift algorithm is suggested. First name, of course. Last name, of course. Phone number is not. It is empty, and this is purposely done because I want to show you that you can actually basically go in and assign your own algorithm. So in this case, I'm going to look for telephone number domain. So under the domain, there are a couple of masking methods. And the first one it suggests is phone SL, secure lookup. I'm happy with that, so I'm just going to save that. So in the same manner, you can also go and change any of the suggested algorithm to a different masking method that suit your application and environment. So the rest of it, postal code is not PII, again, hundreds of thousands of people in the same postal code state as well. It's not PII. So now we are happy with the inventory, and we can go ahead and run the masking job now. So the masking job succeeded. Let's go back to our database here, the masking database, and let's update. The script is pointing to masking database, so let's just update that. So now you can see that the certain columns have changed. Just gonna replay this for a while. So last name, first name has changed, address as well. City, postal code, state and country did not change because that's how we wanted it to be. Phone number and date of birth also has been changed. If you look closely for record 424, the way we handle this date of birth in this particular example, the year and the month remain the same, but the date changed. So in this case, the source database is showing 1980 January the 15th, whereas the mask version is 1980 January the 20th. So you can go down to segmentation of the data and and decide which segment you want to change and which segment you do not want to mask. So in this case, only the date is masked, and this is according to GDPR is good enough. Yeah, because there will be hundreds of thousands or even millions of people that are born in that year, month for that specific city or country. So now the database is masked. Let's go back to our Delphix data engine here. So we are not masking the file system. So right now we will take both of these and we will mount them into our development and our QA environment. But before we do that, we have to take a new snapshot of the mask version of the database, because the previous one that we had is not masked yet. So we want to have the mask version. So we'll just take a quick, and the snapshot is already taken. We might as well also do for the file system, although we didn't really change anything there. So let's take both the latest copy of this mask version and the file system and mount them into dev and QA. So it's going to be the same process as you saw earlier. So this portion here, I will speed it up a little bit. So we've done provisioning the virtual DB, the mask version, to the dev environment, and the database we call it AL-DB dev, and we also mount the file system to the dev environment, and we call it AL-FS dev. Now we'll do the same thing to QA, and again I will speed this up. So now both database AL-DB QA and AL-FS file system QA is now appearing in the QA environment as well. The next thing we'll do is to create Delphix DataPod for self-service for both dev and QA. So we will go into the self-service portal and we will add a new template for our new application called AL. We will choose the data source. In this case is the AL-DB mask, and give it a name. Use the same name here, and we will add the second data source, which is the file system. Again, this will be the AL-FS mask. We use the same name. So both the masking, both the AL-DB mask and the AL-FS mask are the source that we use to create the virtual DB in dev and QA. So therefore, in the template, they should be the data sources. Yeah. Okay, we are done here. So the AL template has been created. Now the next step is to create the DataPods or the container. So the first one we'll do is for the dev environment. We call it AL dev. The owner will be dev, and ALDB dev is correct. ALFS dev is also correct, so it's already pre-selected. So let's just create it. We will also go ahead and let's make sure that it's done first. We should put this in a new tab. Okay, so all the action has been completed. So coming back to the self-service portal. So now we add the second. Let's look at the first container. So it's there. Now let's add the second container. AL QA. The owner is QA, and the last remaining data sets is the QA database and the QA file system. So we are happy with that. Great. And let's make sure it's done before we move on. So while we're waiting, let's log into our target server here. So this is our Postgres target server, where we are hosting both the dev and QA environment. Delphix is our OS user, so let's make sure we SU to Delphix first. We'll do the same thing for. Now I'm using separate windows, although we are logging to the same server. I'm using separate windows just to showcase different environment. The first one was the green screen was for dev, and the blue screen here is for QA. So okay. Now coming back to the portal here, let's look at our container. Both are ready. So the first thing we'll do is we go into the dev environment. That's where everything will start. If you look at the timeline, the default timeline is always there. Now the developer is going to start programming or coding his first code here for version 1.0. So he should branch off to a new branch, and he can call this, for example, version 1.0, and create. So now that's done. Let's go look into his first. I need to grab his file system location. Let's go to his terminal. So the green one is the developer. So we're just going to simulate that he is writing a code now. So if you look at the application folder here, there's nothing except for one directory, sites, which is for a different demo. So to simulate some coding activity, I'm just going to create a file here called app_version 1.0. Okay, so and when you look at it, let's assume that he has completed his task here, created the version 1.0, and now this environment is ready for QA testing. So coming back to the self-service portal and his timeline, which is 1.0. So somewhere along here he has completed his coding, and now at this particular point in time he can bookmark his environment, and he can call it version 1.0 and ready for QA testing. So that is intelligible enough, and let's create that bookmark. Now he would want to share this bookmark, so let's go ahead and share. Now the icon changed slightly, showing that this is a shared bookmark. So let's go now to the QA guy, and the QA guy is again starting with his default timeline. So he's informed that there's a bookmark that is ready, that he can go in, create a branch, and then do some testing. So he'll go ahead and create a parallel branch here, and he can call this version 1.0 QA testing. Create. So looking at his timeline, and that's completed. So before he begins his test, he should basically bookmark this location here now. Let's call this version 1.0 QA pre-test. This is done so that in case he need to rewind his entire environment to the very beginning, he can use this bookmark to do so. So now he can begin his testing. So to simulate his testing, let's just grab his the location of the application first, and we go to his QA environment. So we already log in. So, and if you look at this environment now, since he has just jumped into the bookmark given by the dev guy, so he is now looking at the point in time that the dev person created the bookmark. So you can see the application version 1.0 there. So he's going to start up this application, and then he's going to run a series of tests. So let's just create some marker here to simulate activity. We can call it simply QA running tests. So that's done. So let's say test 1 passes, test 2 passes, and then test 3 he hit some problem. So let's simulate the problem in the database. So first we need to connect to let's connect to dev first. Dev, if you will run the same script, create a new tab for that, and we call this dev. We will also connect to QA, point to QA, script is pointing to QA, create a new tab, call it QA. So as you can see, at this point in time, QA, dev, and mask, they all have the same data, because dev and QA are the virtual DB are children from the masking database, and the mask database is originally the children of source, but since we have masked it, so the data is different. Now we're going to simulate an error in QA. During his test 3, he hit an error. So let's just do some drastic stuff here. So I'm going to update what? Update node last name, and set it to a specific value. Set this field to a specific value, and we're going to just use Lee here. Update last name. Yep. So we're going to run this against QA. That script is pointing to QA now. Okay. So 100 rows have been updated. So now if you go back to QA, it's already pointing to QA, and we're going to refresh this. You're going to see that the test 3 has damaged the database as well. Yeah. So that is the simulation of an error. We go back to timeline. So he has done test 1, test 2, test 3, hit an error. So at this particular point in time, he will bookmark the error condition, and we'll call it v1.0 test 3 intelligible enough, create that bookmark, and he wants to share this bookmark, so make it shareable. Now what he can do while waiting for the developer to pick up the bookmark and fix the problem, he can basically now rewind to his pretest, and we're going to do this now. And basically, once he is fully rewind to the previous bookmark, he can then continue with test 4, 5, 6, or what other tests that he needs to run. So in the meantime, the dev guy has been informed that there's an error. So he looks at the bookmark that was shared by the QA, and he basically can create yet another branch, and he can call this something like version 1.0 bug fix for Lee, and create that timeline. And coming to his timeline, is being created now. You can see that he has the default, which is the one that he started with. He has the version 1.0 timeline, which he developed version 1.0, and now he has been asked to look at this bug, so he create yet another timeline, and that's that. Okay, so that's done. So if we go back to the developer environment, if we go back to here and we try to do an lsltr, basically it will tell us that the directory is stale. So basically what that means is that because we have unmounted his timeline, the file system from his timeline, and mounted the version that is provided by the bookmark, the error bookmark given by QA. So therefore right now we will have to exit this and log in back again as Delphix, cd back to his application folder. And now he's looking at that particular point in time that was shared by the QA when he hit the error. As you can see, the file there, QA running test, that was the simulation of the activity on the QA side. And from the database perspective as well, if we go to dev and we point this to dev, and now the script is pointing to dev. So now you can see that the database is also at the point in time when QA hit the error. So the dev guy can now look at what the problem is and work on his fix. So yeah, that's the demo that I have in terms of self-service and the interaction between, in this simple example, QA and dev. Now, the next thing I'm going to show you is that the entire use case that I just shown you by mouse click can be automated using something like Jenkins. So this particular pipeline here has been created, and basically what it does is exactly the same thing that we did earlier. So the first thing it will do is it will delete the demo bookmark which was created by previous run, and then it will create a QA pretest bookmark and continue to run his test, which will eventually corrupt the data, and then he will create another bookmark and share with the developer, and he will rewind, the QA guy will rewind his environment back to pretest. So the entire thing is automated using this pipeline. Now to look at how the API is used in this particular case, so let's just take a previous run here. It took only 50 seconds to run this whole thing. Well, of course, the test is a very simple test. If your test is, let's say, 20 minutes, then it'll be 21 minutes of run. So the first phase here, as I mentioned, delete previous demo bookmark. So the API that is being called is this bookmark API, and the action is remove. Remove what? Remove a bookmark by the name of pretest from this template and from that container. Yeah, there are two bookmarks to be removed from the previous run, so the second one will do the same thing but on a different bookmark to remove this particular bookmark. So next thing is create a new bookmark. But before that, he will run a script, read DB. which basically the important thing here is to note the number of rows being written is 160,000. And then he'll move on to create his bookmark. Action is create, and the bookmark is called pretest into his container and template. So then he begin to run his tests. So this run test SQL script basically will delete 13,686 rows from the database. And when you run the readDB SQL again, it shows 140 plus thousand rows that's missing that 13,686 rows. Now, so the test has created this error condition. So the next thing is, of course, to share the environment with the dev. So again, the bookmark API, but this time is to create the bookmark, and he called this bookmark QA error 1234, and then make it shareable. So bookmark action share. What are you sharing? This particular bookmark. Okay, so once the bookmark, the error condition bookmark has been created and shared, so the next thing the QA guy do is to basically rewind or rather to restore his environment back to the pretest. So this is a container API now. The action is restore. Restore to what timeline? To the pretest bookmark. And once that is done, he runs his readDB SQL script again, and you see that the entire environment has been rewind or rather restored back to the pretest condition, which is showing 160,000 rows. So that's it for now. Thank you for watching.